Star Dragon is a tech demo I typed in from Compute's Gazette, June 1986. I picked it because it was short and it has dragons in it. Its claim to fame is showing 16 hardware sprites on screen when the C64's VIC-2 chip only supported 8. But that's because it flickered half of them on and off every other frame. The ship's controls in this demo were off though. You used plus and minus to move left and right. Not only is that a reach to do comfortably when using a keyboard, those keys are reversed on modern keyboards. Control to fire is not too bad, but like, I have a joystick. Let's make it work with a joystick. For this, I took the star.prg file MLX2 created off of the virtual floppy I was using with Vice, stripped the 2-byte memory location header, decompiled the code using DA65, and eventually recompiled it with CA65. The GitHub project has all the files and build scripts I used. Let's decompile it, and there's a lot of code in here. So where do we start? All games have a loop they perform. They're roughly like this. Accept input from the user, perform some calculations to update the state of the game, and draw things on the screen based on the game state. We need to find the input part of the loop, so let's look for code that reads what key is being pressed at the current moment. On a C64, you can read most keyboard keys by looking at address CB. The code for the key being pushed right now will end up in there. The keyboard code for plus is 28 and minus is 2B. Searching the code, we find references to those two numbers next to a memory lookup at CB, as well as some suspicious increments and decrements nearby. We found our movement code. Next, let's figure out how to read the joystick. Joystick State comes from reading a pair of MOS Technology 6526 complex interface adapter chips, which handle a ton of input and output processes within the computer. When you push the joystick plugged into the first joystick port in a direction, and or push the fire button, the joystick state can be found as a series of bit reads at DC01, the place where human I/O to CIA1 ends up in memory. We can use a bit mask directly against the value in DC01 to detect whether or not the joystick is being pressed left or right. And now we can move our spaceship with our controller. Finally, let's get the fire button working. Firing was done with the control key. Normally, the C64 will only tell you about a single key being pushed down at CB, but some keys, like control, can be read alongside that single key. This makes it possible to move and shoot at the same time. Control is read from a different spot, O28D, and it's a bit mask, just like reading the joystick. If the value is 4, bit 2 is active, the control key is down, and we can fire a shot toward the dragon, even if we're pushing plus or minus. Replacing this with the joystick is easy. Swap out the checks against O28D with directly checking bit 4 of DC01. Now we can unleash Pixel Fury on our flickering reptile straight from the controller. So, a quick code change to update a control scheme to something more game-like, and a little bit of learning about Commodore 64 human inputs at the same time. All in all, a fun afternoon for a Hackerbun.